Welcome. Today we're diving into the essentials of setting up a basic Android project using Kotlin. If you're new to Android development, this is your perfect starting point. We'll walk through the tools, concepts, and practical steps you need to get your first app up and running. By the end, you'll understand not just how to create a project, but also the core building blocks like activities, XML layouts, and more. Let's get started by exploring what you need and how Android Studio makes your journey smoother. First step in Android development is opening Android Studio, the official integrated development environment for Android. Once you launch it, you'll see an option to start a new project. Android Studio's project wizard automates much of the setup, making it easy for beginners to get started without worrying about complex configurations. This environment is designed to streamline your workflow so you can focus on learning and building. Creating a new project, you'll be prompted to choose a template. For beginners, selecting Empty Views Activity is recommended. This template is ideal for learning traditional XML layouts and Kotlin code. If you're exploring Jetpack Compose, you might choose Empty Activity, but for foundational learning, stick with Empty Views Activity. This sets up a simple structure that's easy to understand and expand as you learn. Next, you'll configure your project details. Give your app a name, such as MyFirstApp. Select Kotlin as the programming language, which is now the preferred language for Android development. Set the Minimum SDK to API 24, Android 7, to ensure compatibility with most devices. These choices lay the foundation for your app and ensure it runs smoothly on a wide range of Android phones and tablets. After configuring your project, click Finish. Android Studio will now generate your project structure and sync with Gradle, the build system. This process sets up all the necessary files and folders so you don't have to do it manually. Once the sync is complete, you'll see your new project ready to explore, with everything organized for you to start coding right away. Let's talk about activities. In Android, an activity represents a single, focused thing a user can do. Think of it as a page in a website. Each screen in your app is typically an activity. For example, a login screen and a settings screen would be two separate activities. When you create a new project, Android Studio automatically generates a main activity file as your app's entry point. Kotlin, every activity extends app-compat activity. The onCreate method is where your activity is initialized. Here, you link your Kotlin code to the XML layout file using setContentView. This setup ensures your code and UI are connected, allowing you to control what happens when users interact with your app. The main activity file is your starting point for adding logic and responding to user actions. XML plays a crucial role in Android development. It's used to design the user interface declaratively. While Kotlin handles the logic, what happens when a button is clicked, XML defines the structure and appearance, such as where buttons are placed, their colors, and text. Android uses a hierarchy of views and view groups to organize your UI elements efficiently. Let's look at a simple XML layout example. The activity main XML file might use a linear layout to arrange widgets vertically. Inside, you can add a text view with properties like text, text size, and layout width. This file defines how your app's main screen looks, and you can easily modify it to add more UI elements as your app grows. Move from one screen to another in your app, you use an intent. An intent is like a message that requests an action from another component, such as opening a new activity. For example, clicking a button in main activity can trigger an intent to start second activity, making navigation seamless for users. How you use an intent in Kotlin. You create an intent object, specify the current and target activities, and call start activity. This simple code lets you switch screens with ease. Intents are fundamental for building multi-screen apps and passing control between different parts of your application. Interact with UI elements defined in XML. You need to reference them in your Kotlin code. Traditionally, this was done using findViewById, which searches the view hierarchy at runtime. However, this method can be slow and error-prone, especially in complex layouts. Modern Android development recommends using ViewBinding for safer and more efficient code. ViewBinding is a modern feature that generates a binding class for each XML layout file. To enable it, add ViewBinding equals true in your build, Gradle, KTS file under build features. This setup ensures type safety and null safety, preventing common errors when accessing views. Once enabled, you can access UI elements directly through the binding object. ViewBinding enabled, you declare a binding variable in your activity. In onCreate, you inflate the layout using the generated binding class and set the content view to binding root. Now, you can access views like binding welcome text directly, making your code cleaner and less error-prone compared to findViewById. RecyclerView is an advanced, memory-efficient way to display scrollable lists in Android. Instead of creating a UI element for every item, which could crash your app with large datasets, RecyclerView only creates enough views to fill the screen and recycles them as you scroll. This approach keeps your app fast and responsive, even with thousands of items. RecyclerView relies on three main components: Layout Manager, View Holder, and Adapter. The Layout Manager decides how items are arranged, vertically, in a grid, or another pattern. The View Holder holds references to the views for each list item, while the Adapter connects your data source to the View Holder, populating the views with data. Together, these components make RecyclerView powerful and flexible. AndroidManifest.xml file is the blueprint of your entire application. The Android operating system reads this file before running any component of your app. It declares all activities, services, and broadcast receivers, defines permissions, sets the app icon and theme, and specifies which activity launches first. Without a properly configured manifest, your app won't function correctly. Typical Android manifest XML snippet includes the package name, permissions like internet, and declarations for each activity. For example, main activity is marked as exported and set as the launcher activity, so it opens when the user taps your app icon. Other activities, like second activity, are also listed to ensure smooth navigation and functionality. Fragments are reusable portions of a user interface within an activity. Think of them as mini-screens or sub-activities that can be combined in various ways. For example, you might use multiple fragments in a tablet layout or swap them dynamically with a bottom navigation bar. Fragments help you build flexible and modular UIs. Fragments have their own lifecycle, closely tied to their host activity. Key lifecycle methods include onAttach, onCreate, onCreateView, onViewCreated, onPause, onStop, onDestroyView, and onDetach. Each method serves a specific purpose, from initializing the fragment to cleaning up resources when it's no longer needed. Understanding this lifecycle is crucial for managing fragment behavior. Let's break down some key fragment lifecycle methods. OnAttach is called when the fragment is first connected to its host activity. OnCreate is for initial setup, while onCreateView is where you inflate the fragment's XML layout. OnViewCreated is called right after the view is created, making it a great place to set up logic and view binding. OnPause and OnStop are triggered when the fragment is no longer visible, and onDestroyView cleans up the view hierarchy. When a fragment is no longer needed, onDestroyView is called to remove the view hierarchy, and onDetach is called when the fragment is completely decoupled from the activity. Properly handling these methods ensures your app manages resources efficiently and avoids memory leaks, especially in complex UIs with multiple fragments. Pass data from one activity to another, you use intents with extras, key-value pairs bundled with the intent. This allows you to send information like a user's name or age to another screen. It's a simple yet powerful way to share data across different parts of your app, making your applications interactive and dynamic. Your main activity, create an intent and use putExtra to add data, such as a user's name and age. Then start the target activity. This method is straightforward and ensures that the receiving activity can access the data it needs to function properly. The receiving activity, retrieve the data using getStringExtra or getIntExtra, providing default values for primitives. This ensures your app handles data safely and avoids crashes if the expected data isn't present. Printing or displaying the received data helps confirm everything is working as intended. Missions in Android are divided into normal and dangerous categories. Normal permissions, like internet access, are granted automatically. Dangerous permissions, such as camera or location, require explicit user approval at runtime. Handling permissions correctly is essential for both security and user experience. Since Android 6, you must request dangerous permissions while the app is running. This means checking if the permission is already granted, and if not, prompting the user to approve it. This approach gives users more control over their data and privacy, aligning with modern security standards. Modern Android apps use the Activity Result API to handle permission requests cleanly. You register a permission callback, which handles the user's response, whether they grant or deny the permission. This method is more robust and easier to manage than older approaches, making your code cleaner and more reliable. Don't forget to declare required permissions in your Android manifest.xml file. For example, to use the camera, add the camera permission. Without this declaration, your app won't be able to request or use the permission, even if your code handles the runtime request correctly. Let's recap the steps for setting up your first Android project. Open Android Studio, select New Project, choose Empty Views Activity, configure your project details, and click Finish. Android Studio handles the rest, generating your project structure and syncing with Gradle. You're now ready to start coding. We've covered the core concepts of Android development: activities, XML layouts, intents, ViewBinding, RecyclerView, the manifest file, fragments, data passing, and permissions. Each of these plays a vital role in building robust and user-friendly Android apps. Mastering these basics sets the stage for more advanced development. Now that you have a solid foundation, experiment with your project. Try adding new activities, customizing layouts, and using ViewBinding to interact with UI elements. Explore RecyclerView for lists and practice handling permissions. The more you experiment, the more confident you'll become in Android development. As a beginner, focus on understanding the relationship between Kotlin code and XML layouts. Use ViewBinding to avoid common errors and always test your app on different devices or emulators. Don't hesitate to read documentation and explore sample projects for inspiration and guidance. Watch out for common mistakes like forgetting to declare activities in the manifest, using the wrong view IDs, or not handling permissions properly. These issues can cause your app to crash or behave unexpectedly. Careful setup and attention to detail will save you time and frustration as you develop your skills. Android Studio offers many features to help you code efficiently, such as code completion, refactoring tools, and built-in emulators. Take time to explore these tools. They can speed up your workflow and help you catch errors early. Familiarity with your development environment is key to productive coding. There are plenty of resources available for learning Android development. Official documentation, online tutorials, and community forums are great places to find answers and examples. Don't hesitate to seek help when you're stuck. Learning is a journey, and the Android community is supportive and active. Debugging is an essential skill for any developer. Use Android Studio's debugger to set breakpoints, inspect variables, and step through your code. This helps you find and fix issues efficiently, ensuring your app runs smoothly and reliably. While emulators are useful, always test your app on real devices when possible. This helps you catch issues related to hardware, performance, and user experience that might not appear in an emulator. Real-world testing is crucial for delivering a polished app. As your project grows, keep your code organized by following best practices. Use clear naming conventions, separate logic into functions and classes, and keep your layouts tidy. Good organization makes your code easier to maintain and scale. Once you're comfortable with the basics, explore advanced topics like Jetpack Compose, custom views, and integrating third-party libraries. These skills will help you build more complex and feature-rich apps, expanding your capabilities as an Android developer. Using version control systems like Git helps you track changes, collaborate with others, and manage your codebase effectively. Android Studio integrates well with Git, making it easy to commit, push, and pull code changes. Start using version control early in your development journey. Android development is constantly evolving. Stay updated with the latest tools, libraries, and best practices by following official blogs, attending webinars, and joining developer communities. Continuous learning ensures your skills remain relevant and your apps stay modern. As you build more apps, showcase your work in a portfolio. Share your projects on GitHub or personal websites to demonstrate your skills to potential employers or collaborators. A strong portfolio is a valuable asset for your career in Android development. The Android developer community is vibrant and supportive. Join forums, attend meetups, and participate in online discussions to connect with other developers. Sharing knowledge and experiences helps everyone grow and succeed together. Congratulations on taking your first steps into Android development with Kotlin. You've learned how to set up a project, understand core concepts, and navigate the essentials of building an app. Keep experimenting, learning, and building. Your journey as an Android developer is just beginning. Good luck and happy coding.